NASA recently shared a series of stunning new images of the interstellar visitor known as Comet 3 I/Atlas, captivating both professional astronomers and amateur skywatchers around the world. The agency held a detailed press conference on November 19, 2025, to present the images collected by a variety of space missions, providing the public with the clearest and most up-to-date view of this fascinating celestial object. The conference began with Associate Administrator Amit Kshatriya reassuring attendees and viewers that, despite rampant speculation on social media, 3I/Atlas is indeed a comet and shows no evidence of being related to extraterrestrial life or any form of artificial structure. This clarification was important, as in the weeks prior to the announcement, discussions across forums, social media platforms, and even mainstream media had grown increasingly sensational, with some claiming the comet could be a mysterious alien artifact visiting our solar system. Kshatriya emphasized that while 3I/Atlas is unusual due to its origin in another star system, its characteristics and behavior are consistent with those of comets observed within our solar system, particularly in how it reacts to close encounters with the Sun. The new images themselves are breathtaking, revealing intricate details of the comet's structure that were not visible in earlier observations. Astrophotographers Michael Yeager, Gerald Riemann, and Enrico Prosperi were among the first to capture early views of 3I/Atlas as it moved away from its closest approach to the Sun, which occurred on October 29, 2025. These images, shared on the ICQ Comet Observations page on Facebook, allow astronomers and enthusiasts alike to track changes in the comet as it reacts to the intense solar radiation and gravitational forces encountered during its perihelion, the point at which it passed closest to the Sun. The photographs show dramatic jets of material streaming away from the comet's nucleus, a phenomenon commonly observed in comets, but particularly striking in this case, given the comet's interstellar origin. These jets indicate that 3I/Atlas is actively shedding gas and dust, forming a complex halo and contributing to the spectacular tail that trails behind the comet, a visible signature of its dynamic interaction with the Sun's heat and radiation. Despite its visual impact, 3I/Atlas remains invisible to the unaided human eye. Observers who wish to see it will require a telescope with at least an 8-inch, 20 centimeters, aperture or larger to discern the details of its bright nucleus and the streaming jets of dust and gas. The best opportunity to view the comet is during the pre-dawn hours in late November, when it is positioned in the eastern sky just before sunrise. Amateur astronomers equipped with medium to large-sized telescopes are encouraged to attempt observations during this period, as the comet is expected to remain bright enough to provide a remarkable viewing experience. Even from a distance, the combination of the bright core and the expansive tail makes for a visually stunning celestial display, and the presence of multiple active jets adds a layer of complexity to its appearance, creating a spectacle that is both scientifically valuable and aesthetically remarkable. In addition to ground-based observations, several space-based missions have turned their instruments toward 3I/Atlas. Notably, the European Space Agency's Jupiter Icy Moons Explorer JUICE is actively observing the comet between November 2nd and 25th, 2025. The mission suite of scientific instruments allows for detailed study of the comet's composition, activity, and trajectory, providing data that complements what astronomers can capture from Earth. By observing 3I/Atlas shortly after its closest approach to the Sun, JUICE has the unique opportunity to document the comet in a highly active state. Solar heating during perihelion causes sublimation of ices and the release of gas and dust, resulting in a bright, glowing halo surrounding the comet's nucleus, and the formation of an extended tail stretching for millions of kilometers through space. The combination of these features makes the comet an ideal subject for study, offering insights into the composition and physical properties of an object that originated outside our solar system, potentially carrying materials that have never been sampled by any previous missions or telescopic observations. The observational data gathered from both ground-based telescopes and space missions is invaluable for understanding the behavior of interstellar comets. Unlike comets formed in the solar system, Interstellar objects like 3I/Atlas have traveled for millions of years through the vast emptiness of interstellar space before entering our solar system. This journey exposes them to conditions far different from those experienced by comets formed locally, including extreme cold, cosmic radiation, and the gravitational influence of distant stars. Studying such objects provides astronomers with a rare glimpse into the chemistry, physical structure, and evolutionary history of materials from other star systems. By comparing the activity and composition of 3I/Atlas with that of typical solar system comets, researchers can refine models of comet formation and evolution, and potentially gain insight into the processes that shape planetary systems beyond our own. The collaborative effort of professional astrophotographers, amateur astronomers, and space agencies highlights the importance of combining multiple perspectives when studying rare cosmic events. High-resolution images from skilled astrophotographers like Yeager, Riemann, and Prosperi allow the scientific community to track the comet's morphological changes in near real time, while data from instruments aboard JUICE, as well as other observatories, provide quantitative measurements of the comet's gas composition, dust production rates, and interaction with the solar wind. This multifaceted approach is crucial for understanding complex phenomena like the development of multiple jets, variations in tail structure, and changes in brightness over time. As 3I/Atlas continues its journey away from the Sun and eventually exits the inner solar system, ongoing monitoring will help scientists document how interstellar comets evolve after exposure to intense solar radiation and gravitational forces, offering rare longitudinal data on such objects. The public engagement generated by 3I/Atlas also emphasizes the growing interest in astronomy and space exploration worldwide. Social media platforms, online forums, and astronomy clubs have been actively sharing observation tips, images, and updates about the comet, creating a global community of enthusiasts tracking its progress. The excitement surrounding the comet demonstrates how remarkable celestial events can inspire curiosity, foster learning, and unite people across different countries and cultures in a shared appreciation of the universe. NASA's transparency in sharing images and holding public briefings further strengthens this connection, allowing enthusiasts to follow the comet's journey and understand the scientific processes involved in its observation and analysis. In conclusion, the latest images of Comet 3I/Atlas, combined with ongoing observations from ground-based and space-based platforms, offer an unprecedented look at an interstellar object passing through our solar system. From the spectacular jets streaming from its nucleus to the expansive tail stretching behind it, the comet provides both a stunning visual display and a wealth of scientific information. Whether observed through a telescope by dedicated amateur astronomers, studied in detail by professional astrophotographers, or analyzed by sophisticated instruments aboard missions like JUICE, 3I/Atlas represents a rare opportunity to explore materials from another star system and understand the dynamics of interstellar visitors. Its journey past the Sun, its bright halo, and active jets remind us of the immense beauty and complexity of the cosmos, and the importance of continued observation and exploration. As we look to the skies in the coming weeks, the comet will serve as both a scientific treasure and a source of wonder, inspiring curiosity and awe in all who take the time to witness its passage. The combined efforts of scientists, astrophotographers, and space agencies ensure that the story of 3I/Atlas will be remembered not only as a significant astronomical event, but also as a testament to humanity's enduring fascination with the universe beyond our home planet.